In the autumn of 1347, 12 Genoese trading ships docked at the Sicilian port of Messina. Within weeks, the people unloading them began to die. Within 5 years, somewhere between 25 million and 50 million people across Europe were dead. Whole villages emptied. Cities lost half their population in a single summer. And buried inside the catastrophe was a question no one could answer for nearly 7 centuries. In households where every member fell sick, a few people lived. Not the wealthiest, not the most isolated, not the ones who fled. They breathed the same air, drank the same water, slept beside the same dying bodies, and they survived. For 700 years, that survival had no biological explanation. Then ancient DNA was extracted from the bones of the dead, and what came back rewrote the story. The Black Death did not just kill people, it rewrote the human genome. To understand what the DNA was answering, you have to understand the world the plague walked into. Europe in the late 1340s was a continent without germ theory, without antibiotics, without any concept of contagion as biology rather than morality. Disease was understood as a punishment, a poisoning of the air, an imbalance of the four humors, an act of a wrathful god. Medicine was practiced by men who bled their patients to drain corruption from the body, who prescribed herbal sachets and rose petals to ward off foul vapors, who recommended that the sick sit between 2 roaring fires to burn the sickness out of the room. None of it worked. None of it could have worked. The bacterium responsible for what would become the Black Death would not be identified for another 547 years. The arrival is recorded with a precision that almost no other catastrophe of the medieval period possesses. In October 1347, 12 Genoese trading ships put in at the Sicilian port of Messina. The sailors aboard were already dying. The harbor officials ordered the ships out of port within days, but it was already too late. From Sicily, the plague moved north and west, across the Mediterranean, into the Italian mainland, into France, into the British Isles, into Scandinavia, into the Baltic. By 1351, it had reached Russia. In 4 years, it crossed a continent. It arrived in 3 forms, and the forms mattered. Bubonic plague, the most common, was carried by fleas living on rats and spread through their bites, producing the swollen lymph nodes, the buboes, that gave the disease its name. Pneumonic plague colonized the lungs and spread through the air, transmitted by a single cough across a crowded room. Septicemic plague entered the bloodstream directly and killed within hours, sometimes before the victim even understood they were sick. All 3 forms were caused by the same bacterium. All 3 forms were almost universally fatal to the medieval population that encountered them. The death toll arrived faster than the historical record could process it. Florence lost more than half its inhabitants in a single year. Paris recorded 800 deaths a day at the peak. Some English villages were emptied so completely that their fields lay uncultivated for a generation. Mass graves were dug, filled, and dug again. Bodies were stacked in layers separated by thin coverings of earth. Loved ones abandoned the dead in the streets because there was no one left to bury them. The estimate that has settled into the historical consensus is 25 to 50 million dead in Europe alone, somewhere between 1/3 and 60% of the entire population of the continent. Global estimates climb toward 200 million. There has never been another mortality event in recorded human history that came close. Not influenza in 1918, not smallpox in the Americas, not the Antonine Plague of Rome. The Black Death stands alone in the demographic record as the largest single subtraction of human beings from the planet that has ever been documented. And inside that subtraction sat a pattern that no one in the 14th century could see and no one in the centuries after could explain. Some people did not die. They were not richer, not better fed, not better hidden. They were standing in the same plague rooms, breathing the same plague air, touching the same plague bodies as the people who fell beside them. And they lived. The question of why would take nearly 7 centuries to answer. The pattern was visible to anyone who looked closely at the historical record, but for centuries no one could explain what they were looking at. In the chronicles of monks who survived to write about what had happened, in the parish registers of priests who buried their entire congregations, in the household accounts of families that lost everyone except a single daughter or a single grandfather, the same strange detail kept appearing. Plague did not take everyone. In rooms where 6 people fell sick, 4 would die and 2 would walk out. In villages where the death toll reached 70%, the remaining 30% were not simply the lucky ones who had managed to flee. Many of them had stayed. Many of them had nursed the dying. Many of them had been exposed to the disease in every possible way that should have killed them. And they lived. For most of the next 700 years, the explanation defaulted to whatever the prevailing worldview required. In the medieval period, survival was framed as divine grace, a mark of righteousness, a sign that God had spared the worthy and condemned the wicked. In the early modern period, as the religious framing softened, the explanation shifted to constitution, to humors, to the vague notion that some bodies were simply stronger than others. By the 19th century, the survivors were being explained through environmental theory, through diet, through the cleanliness of the houses they happened to occupy. None of these explanations actually held up against the evidence. Survivors were not consistently wealthier. They were not consistently better fed. They were not consistently isolated. The pattern of who lived and who died cut across every social, economic, and geographic line that historians tried to draw through it. The scientific framing of the question began to take shape only in 1894. That was the year the Swiss-French bacteriologist Alexander Yersin, working in Hong Kong during a later plague outbreak, identified the bacterium responsible. It was named Yersinia pestis in his honor. For the first time, the disease had a biological cause that could be studied, cultured, and tested in a laboratory. And yet the survivor question remained completely unanswered. Identifying the pathogen was not the same as explaining why some humans could withstand it. The bacterium was the same. The exposure was the same. The outcomes were not. Through the 20th century, the question circled in a kind of scientific stalemate. Researchers could now describe in precise detail how Yersinia pestis moved through the body, how it suppressed the immune response, how it caused the buboes and the hemorrhaging and the rapid systemic collapse that defined the disease. But the question of why one person's immune system collapsed in 48 hours while another person's immune system held was a question that bacteriology alone could not answer. The answer, if there was one, had to be inside the survivors themselves, inside their cells, inside their genome. But the genome of a 14th century plague survivor is not something that the 20th century knew how to read. The DNA of the long dead was understood to be too fragmented, too contaminated, too degraded by 700 years in the ground to yield any usable information. The bones in the plague pits of London and the cemeteries of Denmark and the burial trenches of Florence sat in archaeological collections, holding the answer to a question that the technology of the time could not yet ask. And then the bones began to speak. Ancient DNA sequencing is the technology that made the question answerable. By the 2010s, researchers had developed methods refined enough to extract readable genetic material from skeletons that had been buried for centuries, sequence it against modern genomes, and reconstruct in detail the biological state of populations that had been dead for half a millennium or more. What the technology offered was a kind of biological time machine. The bones in the plague pits were no longer silent. They were a record waiting to be read. October 2022, a team of researchers led by Hendrik Poinar at McMaster University and Luis Barrero at the University of Chicago published their findings in the journal Nature. The study had been years in the making. The researchers had extracted DNA from more than 500 skeletons buried at 3 sites with extraordinarily precise chronological layering. The East Smithfield plague pit in London, dug in 1348 specifically to receive the bodies of Black Death victims as the disease overwhelmed the city's churchyards. 2 cemeteries in Denmark with continuous burials spanning the centuries before, during, and after the plague. The chronological precision mattered. It allowed the researchers to do something that had never been done before in evolutionary genetics on this scale. They could compare the genomes of 3 distinct populations: the people who lived before the plague arrived, the people who died in it, and the people who lived in the same regions afterwards. What the comparison revealed was a signal so strong it forced an immediate reconsideration of how natural selection works in human beings. Certain immune system gene variants appeared in the post-plague population at significantly higher frequencies than they had in the pre-plague population. Variants that had been present in only a fraction of medieval Europeans before 1348 had become dramatically more common in the same regions within a single generation. This was not genetic drift. Drift is slow, drift is random. This was selection, the most rapid and powerful selection event ever documented in the human genome, captured in the bones of the people it had filtered. One gene stood out above all the others: ERAP2, endoplasmic reticulum aminopeptidase 2. In plain terms, ERAP2 produces a protein that helps the immune system recognize pieces of invading pathogens and present them to immune cells, the cells that identify and destroy infected tissue. 2 versions of the ERAP2 gene exist in humans. One produces a fully functional version of the protein. The other produces a truncated, less effective version. Before the plague, both variants existed in the medieval European population at roughly similar frequencies. After the plague, the functional variant had surged. The selection pressure had been overwhelming. The numbers are difficult to absorb. Researchers calculated that individuals carrying 2 copies of the protective ERAP2 variant were roughly 40% more likely to survive the Black Death than individuals carrying 2 copies of the non-protective variant. A 40% survival advantage in a single generation, in a single mortality event, is selection at a speed that geneticists had previously believed was impossible in a long-lived species like humans. The kind of evolutionary pressure typically associated with bacteria reproducing in petri dishes, with insects in pesticide trials, with timescales measured in days, had been recorded in human DNA across the span of a few terrible years. The Black Death had not simply killed people. It had filtered them. It had selected, with the indifferent precision of bacterial physiology, who would live to reproduce and who would not. It had edited the species. The protective ERAP2 variant did not vanish when the plague ended. It could not. The selection event had concentrated it in the survivors, and the survivors had children, and the children inherited it. Within a few generations of the Black Death's worst years, the genetic frequency of the protective variant had risen to a level that ordinary evolutionary pressure would have required thousands of years to produce. The mutation that had given certain medieval Europeans a fighting chance against Yersinia pestis became, through the simple arithmetic of who lived to reproduce, a permanent feature of the population that came after. This is why the discovery is described as a fingerprint of the plague, still detectable in the genomes of living human beings 7 centuries later. Modern Europeans carry the protective ERAP2 variant at significantly higher frequencies than the pre-plague population did. The signal is faint enough that it took ancient DNA sequencing to identify it, but it is real, and it is measurable, and it is sitting inside hundreds of millions of people walking the streets of London and Paris and Copenhagen today. The plague that emptied medieval cities is still inside the cells of the descendants of those who survived it. ERAP2 was not the only variant that surged. The 2022 study identified several immune-related genes that showed similar selection signatures, a constellation of small genetic adjustments that together gave the survivors and their descendants a more aggressive, more responsive defense against bacterial infection. Earlier research had also documented distinct gene clusters in certain populations that conferred plague resistance. The pattern was consistent. The plague had not selected for a single magic mutation. It had selected for an immune system tuned more sharply against the specific kind of pathogen that Yersinia pestis represented. But the human genome does not produce free gifts. Every adaptation carries a cost, and the cost of the immune system that survived the Black Death has begun to surface in the medical literature only recently. The same ERAP2 variant that helped the survivors fight off plague bacteria is now associated with significantly higher rates of autoimmune disease in their descendants. Crohn's disease, rheumatoid arthritis, inflammatory bowel conditions. The pattern is consistent across multiple studies. An immune system tuned to identify and destroy invading pathogens with greater aggression is also more likely to misidentify the body's own tissue as a threat and attack it. This is the trade-off the survivors did not know they were making. They lived. They passed on the variant that allowed them to live. And they passed on, in the same biological transaction, a heightened susceptibility to a category of disease that would not even be understood as a category until the 20th century. The descendants of the plague survivors are statistically more likely to develop autoimmune conditions than the descendants of populations that were not subjected to the same selection pressure. The bill for surviving the Black Death is still being paid in clinics and hospitals, in chronic disease registries, in the slow grinding inflammation of immune systems that were forged in the plague pits of medieval Europe. The reframing this forces is genuinely disorienting. Every person of European descent walking around today is, in some statistical sense, the product of who survived the Black Death. The immune systems of the living are the immune systems of the survivors. The vulnerabilities of the living are the vulnerabilities of the survivors. The plague did not end in 1353. It ended, if it ended at all, inside the cells of every descendant who carries the ERAP2 variant today. Genetics was the silent variable underneath the catastrophe, but it was not the only variable. Survival during the Black Death was a layered phenomenon, and the visible layers, the ones the chronicles recorded and the laws prescribed, mattered. They mattered enormously. The cities that imposed strict containment measures saw mortality rates dramatically lower than the cities that did not. Milan, under the brutal direction of its ruling Visconti family, ordered the houses of plague victims walled up with the families still inside, healthy and sick alike, sealed in to die together rather than risk spreading the disease. The policy was savage. It was also effective. Milan ended the first wave of the Black Death with a mortality rate around 15%, the lowest of any major Italian city. Venice took a different approach, calibrated to its position as a maritime trading power. By 1348, the city had established a 30-day holding period for ships and travelers suspected of carrying the disease, requiring them to remain offshore before being allowed to dock or enter. The period was later extended to 40 days. The Italian phrase for 40 days is quaranta giorni, and from that phrase, used in Venetian port records in the middle of the 14th century, the modern word quarantine descends directly. Tens of thousands of Venetians still died in the plague years, but the policy slowed the rate of arrival enough to spare the city a worse outcome. Geographic isolation provided another buffer. Cold climates and remote regions delayed the plague's arrival until later waves, and some upland villages and northern settlements escaped the worst years entirely. The plague preferred warmer weather. It struggled in winter. Norway saw 30 plague outbreaks between 1348 and 1654, but almost none of them began in the winter months. The fleas that carried the bacterium did not move well in the cold, and the populations of the far north got something close to a seasonal reprieve that the Mediterranean cities never received. Health mattered as well. The malnourished, the elderly, those already weakened by other diseases or chronic conditions, died at significantly higher rates than the healthy. The medical research is consistent with what common sense would suggest. A body fighting a secondary battle against scurvy or tuberculosis or simple starvation had less reserve to fight the plague when it arrived. The wealthy, who could afford to flee the cities and isolate themselves on country estates, survived in higher numbers than the poor, who had nowhere to go. But the plague cut across class lines more than the wealthy expected. Cardinals died. Bishops died. The royal courts of England and France lost members in significant numbers. Money bought distance, but distance was not always enough. Protection was real, but limited. The leather plague suits worn by physicians, with their long beaked masks filled with herbs and rose petals, did provide some genuine defense, not because the herbs neutralized any miasma, but because the leather kept fleas off the skin. Avoiding the dead, burning bedding, washing in vinegar, distancing from the sick, all of it reduced exposure to some degree. None of it overrode the bacterial onslaught entirely. Underneath all of this sat the genetic variable. Two people with identical exposure, identical health, identical behavior, identical wealth could have opposite fates because of a difference in immune system genes that neither of them knew they carried. The visible responses to the plague, the laws and the quarantines and the masks, were debated and recorded and remembered. The genetic response was invisible. Until now, it had no historian. The discovery has implications that reach well beyond the medieval period. The Black Death is now understood as the strongest documented evolutionary pressure event in recent human history, the clearest case ever recorded of natural selection acting on a long-lived species at a speed that previously belonged only to bacteria and insects. The 2022 study did not just answer a 700-year-old question about plague survivors, it established a model. Pandemics shape genomes. Pandemics leave fingerprints. And those fingerprints can be read decades or centuries later in the cells of the descendants who carry them without ever knowing they do. That model is now being applied to other diseases. Researchers are looking at the smallpox epidemics that swept the Americas after European contact, asking which gene variants in surviving indigenous populations may have been selected for through the same brutal arithmetic of who lived to reproduce. They are looking at tuberculosis, which has been with the human species long enough to leave selection signatures in multiple populations across multiple continents. They are looking at the 1918 influenza pandemic, and most urgently, they are looking at COVID-19. Researchers studying the genetic data of people who recovered from severe COVID infections are asking whether a similar process is happening right now, in the present generation, in real time. The answer is almost certainly yes. The selection pressure of COVID-19 was orders of magnitude weaker than the Black Death, but the principle is the same. Pandemics filter populations. Filtered populations pass on the filter to their children. The cost side of the equation has also become unavoidable. Every adaptation has a trade-off, and the trade-offs of the Black Death are still being totaled. The autoimmune diseases that have risen sharply in modern populations, Crohn's disease, rheumatoid arthritis, inflammatory bowel conditions, are now understood to be linked, at least in part, to the same immune system genes that the plague selected for. The medical establishment is only beginning to grapple with what this means. A disease that swept Europe 7 centuries ago is sitting in the diagnostic histories of people in modern hospitals, in the form of conditions that no medieval physician could have imagined and no modern physician initially connected to it. The reframing this forces on the historical narrative is fundamental. The Black Death has always been described as an event that Europe survived, a catastrophe that the continent endured before recovering and moving on. That description is incomplete. The Black Death was not an event that Europe survived. It was an event that changed what European meant, biologically. The genetic profile of the population that lived in Europe in 1340 and the genetic profile of the population that lived there in 1400 are measurably different. The plague did not just kill people, it produced a different population. The Europeans of the post-plague centuries, the Europeans of the Renaissance, the Europeans of the Enlightenment, the Europeans of the modern era, were all walking around with immune systems that had been forged in the plague pits of the 14th century. They did not know it. They had no way of knowing it. The evidence was being recorded inside them, in their bones, waiting for a technology that would not exist for another 600 years. The medieval Europeans who lived through the worst years of the Black Death did not know they were rewriting their species. They were trying to survive the next morning. And in the act of surviving, they passed something forward that has been moving through human bodies ever since. The answer to the survivor mystery was not lost. It was simply unreadable. For 700 years, it sat in the bones of the dead, in the cells of the living, in the genome of every descendant who carried it forward without knowing what they carried. 25 to 50 million who died in the Black Death left behind more than empty villages and mass graves. They left behind a genetic signature that shaped every European generation that came after them. The people who survived the plague are not distant historical figures. Their immune systems are our immune systems. Their adaptations are our adaptations. Their trade-offs are our trade-offs. The Black Death did not end in 1353 when the death toll finally slowed. It ended, if it ended at all, inside the cells of every descendant alive today. The mystery was not solved by digging deeper into history. It was solved by looking inside ourselves.